Okay, so we're going to try to do balancing equations here. Okay, so remember the stuff on the left side of the equation, each of these atoms have to balance with what's on the right. So these are called reactants and these are called products. So each of these atoms, you see sodium here on the reactant side, there are 3. Sodium in the product side are 1. Okay, there's only 1 sodium in the product side. Okay, so these are my reactants. So we have to balance each of these atoms. Now, how many sodium do we have? This is how I want you guys to do the balancing. Okay, ask yourself these questions just like I'm asking myself. How many sodiums do I have on the left side of this arrow? Okay, left side of the arrow in the reactants, I have 3. How many sodium do I have in the products? I have 1. So let's go ahead and put a 3 here. Now, what I noticed students doing was they were going ahead and putting 3 here. You cannot do that. You've changed the identity of the chemical, okay? So that is wrong, okay? So you cannot do that. The only way to balance is by putting these coefficients. These are called coefficients, okay? That is all you can do is place these coefficients here to balance the equation, all right? When you do that though, when you place this 3 here, this 3 makes the sodium 3 and the fluorine 3. When you see 1 sodium here, it's 1. Fluorine is 1. So total fluorine you have is 1 times 3 is 3. Sodium is 1 times 3 is 3. So you have 3 sodium on the right side and 3 fluorine. Now, let's take a look at our, let's completely balance this formula now. So we have 3 sodium here. We went ahead and put a 3 here in the product side to balance the sodium. We have 1 phosphorus in the reactant side. We have 1 in the product side. Leave it alone, okay? You don't need to do anything for this formula. This formula is balanced. Let's go ahead and put a 1 here. Now, let's look at this one. Rubidium is 1 in the reactant side. Rubidium is 3 in the product side. So I'm going to go ahead and put a 3 here. When you put this 3 once again, the fluorine now is 1 times 3 is 3. Okay, so you take the subscript, which is this 1, because I see 1 fluorine, I went ahead and put a 1, that's 1 fluorine. So 1 times 3 is 3. And then you have this fluorine here, 1 times 3 is 3. So your equation is balanced, all right? And now, what type of equation is this? This is a double replacement. How do I know that? I have A, B, and C, D, and then they're swapping partner. I have A bonding with D here, and B, I have B here and C here, okay? So they're swapping partners, and that's double replacement. Let's do the next one. The next one is also double replacement, all right? The other trick that I told student was if you have 4 elements in the equation on left and 4 on the right side, it's going to be double replacement. So you have sodium is 1, phosphorus is 2, rubidium is 3, and fluorine is 4, all right? And that's a double replacement. Let's take a look at this one. Once again, you can start with any of this formula, okay? So if you want, we can start with this right here. Lithium is 2 in the reactant side. Lithium is 1 in the product side. So let's go ahead and put a 2 here. Remember, you cannot do this. That is wrong, okay? That is wrong. You cannot put subscripts. The only thing you can do is you can put coefficients. So lithium is 2 now. How many sulfurs we have in the reactant? We have 1 sulfur. If you see 1, there is 1, okay? This makes this sulfur is also 1, okay? So we don't need to do anything. Let's go ahead and put 1. Let's look at the magnesium chloride, MgCl2 right here. We have 1 magnesium. We have 1 magnesium. Our magnesium looks pretty balanced, okay? Chlorine in the reactant, we have 2. Chlorine in the products also, we have 2. Well, you're probably looking at it and you're going, oh no, it's 1. No, we have 2 because look, 1 times 2, this coefficient that you put here, this 2, is also for this chlorine as well. It's distributive properties. You remember distributive properties? It's like this. Pretend there's a parentheses. Whatever is inside gets multiplied with that, okay? So we have 2 chlorines. This equation is balanced, and that's a double replacement equation. I'm tired of this red pen. Let's change this to this one. That looks nice. All right. I told you guys to skip this. We'll do this today, okay? So these actually are called combustion reactions. Skip those for now. There's a certain rules you have to follow with those, okay? And if you notice, the identity of combustion reaction is always going to have carbon, hydrogen, and oxygen. Okay, so you look carbon, hydrogen, oxygen, carbon, oxygen, hydrogen, oxygen. That's all you see in the equation. Okay, just 3 elements, carbon, hydrogen, or oxygen, and they're bonded differently. We're going to come back to those later. Let's look at number 4 right here. We can start with, once again, with any formula. To me, it doesn't make sense to start with, it does not make sense to start with PB, because PB is 1, PB is 1. I want to start with something complicated. So I suggest let's start with this. Anytime you see in a formula with something complicated, because with more subscripts, start with that. We have 2 iron here in the reactant side. We have 1 here. Let's go ahead and put 2 here. Now remember, sometimes you have to come back and fix these, okay? So make sure you're doing this work with pencil. I have 3 oxygen in the reactant side. I have 2 in the product. To make these even, the common factor on the multiplication of 2 and 3 is 6. 2 times 3 is 6, and 3 times 2 is 6. So let's make this oxygen 6 by multiplying with 3. Let's make this oxygen in the reactant side by multiplying with 2. Now look what happened. When I put this 2 here, this made my iron 4. 2 times 2 is 4, which means I need to fix this right here. So let's go ahead and fix that. 4. Okay. Now, how many leads do we have in the product side? We have 3. 1 times 3 is 3. Let's go ahead and put a 3 here. This equation is balanced. What type of equation is this? Remember, I told you if you have 3 elements, it's like this: A, C, D. All right. If you have 3 elements, then that is a single replacement. Okay, single replacement. Now let's go ahead and balance the number 5 here. We have 1 calcium here, 1 carbon. Let's do 1 element at a time. 1 calcium here, 1 calcium here. We're good. We don't need to do anything. We have 1 carbon in the reactant side. We have 1 carbon in the product side. We're good. Oxygen we have in the reactant side at 3. Now look at the oxygen. The total oxygen that you have in the product side is 2 plus 1 right here, 3. This whole equation is balanced. Remember, once again, you're balancing each of these elements from the left side, from the reactant to the product. So you have to add these up, okay? So you have 2 oxygen here and 1 more, that's 3. So this equation is balanced, and all you get is to do is just put 1, 1, 1. This type of equation where you start with the combined formula, it's like one thing, okay? One compound. And then in the products, it's split up. This one is called a decomposition. Okay, decomp. They're breaking up, okay? They're breaking up. In the reactant, it was 1, and in the products, it's breaking up. I could keep going and do the whole worksheet. If you guys need it, let me know. I'll post this on Canvas. I hope this was a help. You know, let's see. If you guys need me to do any other, once again, let me know. All right.